Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so without wasting much time, let us move on to our topic that we have been discussing. Once again, welcome to our channel. We are today with a new video. Okay, so we have been discussing about refraction through lens. In the previous class, we have discussed about the various types of lens and what actually the meaning of lens is, whether we can regard the lens as spherical lens. We have discussed all these factors. Today, we will be defining some technical terms related to lens. Okay. So, let us come to the technical terms. So, today we will be mainly discussing the technical terms related to lens. So, technical terms related to lens. So this is today topic of our discussion. Fine. So what are the technical terms? Let us come to the point one by one. So first of all, we will be discussing about the point number one is center of curvature. Now what is center of curvature? Let us discuss in details. See, we have already told that the lens that is being manufactured is a part of a large sphere. So, if we consider a sphere, definitely it has a center, isn't it? So, just let us imagine a sphere. This is a sphere, not a circle. We are actually trying to imagine the 3 dimension in 2 dimension. So, this is a sphere. Okay, and if you think that you have cut out a lens from this sphere, okay, so you have cut out a portion of the lens from this sphere. Say you have cut out from this portion, okay. Another, if you consider this forms a convex lens, plano convex lens, okay, and if you consider it has been cut out like this, so it will be a biconvex lens, isn't it? We have discussed all these terms, biconvex, plano-convex, okay, we have discussed the terms. So this is a biconvex lens, okay. So in both these cases, can you identify that there are two spheres? Obviously, so there will be two center of curvatures, isn't it? So two center of curvature. If I consider a biconvex lens, definitely there will be two center of curvatures, okay. If you consider a plano-convex lens, then it will have one center of curvature. In case of biconvex lens, there are two spheres involved, so there will be two center of curvatures. So this center of the spheres of which the lens is a part can be regarded as the center of curvature. So how can you define center of curvature? Center of curvature is the center of the two spheres of which the lens is a part. So that is the definition of center of curvature. If I consider a concave lens, isn't it? Concave lens, definitely in case of concave lens also, there will be two spheres, isn't it? In case of concave lens, there will be two spheres, right? So these are the two spheres. And you can see that the concave lens is found in between here, isn't it? Okay, so this is the convex part and this is the concave part, okay. So definitely in this case of concave lens also there are two spheres, each having its own center, isn't it? And that center can be regarded as the center of curvature of the lens. There are two center of curvature, C1 and C2. Next important technical term that we are saying is the radius of curvature. Now definitely you can guess a little bit after I have discussed about the definition of the center of curvature, that when you consider the radius of curvature, see, radius of curvature, what happens, as there are two spheres involved in the formation of a either biconvex or biconcave lens, definitely there will be two radius, isn't it? Here in this case, in the case of the convex lens, if I consider, so this is the one radius and this is the other radius, okay. So there are two radius, so these two radius of the two spheres can be regarded as the radius of curvature. In case of concave lens also, there are two radius, isn't it? This one and this one, okay, fine. So there are two radius, so these are the two radius of curvature in both the cases, okay, fine. So these are the radius of curvature. So if I define the radius of curvature, you can define it like this, that the radius of the two spheres of which the length is apart is regarded as the radius of curvature of the two lengths. Okay. Now coming to the next point. So I think the center of curvature and radius of curvature, both these points are clear. Okay. Now coming to the next point. Third point is the principal axis. Third point is the principal axis. So what is the principal axis here? See, in both the cases, concave or convex, the line that joins the two central curvatures can be considered to be the principal axis in both the cases. So if I consider the figures, C1, C2 is the principal axis for the lens. It passes to the center of the lens. Okay, somewhat center of the lens. So principal axis can be defined as the line, imaginary line joining the central curvatures, two central curvatures of the lens. That is the principal axis. Now, third point. Okay, so this is the third point. Fourth point coming is the optical center. Optical center. I think in class 9 you have all read about the term pole in case of mirror, isn't it? What was the definition for pole? It was the geometrical center of the surface of the mirror was regarded as pole. Now, in case of lens also there is definitely a geometrical center, isn't it? So if I just consider the figure here, so if I just draw another symmetrical line in between here, somewhere in between here, it will be the central point. The figure is exactly not accurate, but okay, you can understand from the figure. So these 2 points are the geometrical centers of the lens, isn't it? Geometrical centers of the lens. So this geometrical center of the lens is called the optical center of the lens. So I think the definition of optical center is clear. Now here is one important thing to note, that what happens when a light is actually incident at the optical center. In that case, when a light is incident at the optical center, the light is refracted, but it is refracted parallelly. It is refracted parallelly. Okay. So, and in case of thin lens, if I consider this to be two thin lenses, then light falling at the center of curvature, at the optical center, is not at all refracted. It just passes straight through. So once again I am repeating, in case of thick lens, a bit thicker lens, optical center is the point on which the incident light falls and it gets refracted parallelly. As you have seen in the case of parallel sided glass slab, the right ray, emergent ray is parallel to the incident ray. Same is the case here. And in case of we consider thin lens, very thin lens, then optical center is such a point at which the incident light will fall and will pass undeviated or unrefracted. Okay, so if I consider these two lenses to be very thin, then the ray of light falling on the optical center will just pass away like this. Okay, so I think the figure is clear to all of you. And here also, if a light falls on the optical center, it will pass undeviated like this. Okay, so this is another important point regarding the optical center. First of all, it is the geometrical center for the lens. That is one point. And the second point is that it is such a point on the lens, in the lens, through which light passes undeviated without being refracted. Okay. So this is the optical center. Now, what is the next point? So let us erase this figure. If you have not noted it, please pause the video, move back a little and watch the video once again. I think the concept will be clear. Now the fifth point that needs to be discussed is the focal point. Focal point. So I will be first discussing the focal point, or it can be also regarded as the focus. So I will be discussing the focal point or focus for convex lens and then for concave lens. Now, see, if I draw a convex lens, consider this a convex lens, okay. So the convex lens has a principal axis, isn't it? The convex lens has a principal axis. So the principal axis is passing through the middle, okay. Okay. Now what happens? There are two focal points on this principal axis. Two focal points on this principal axis. One is regarded as f1 and another is regarded as f2. So this is f1 and this is f2. First focal point and second focal point. Okay. So what happens? First focal point is that point for a convex lens we are discussing. First focal point is that point on the principal axis at which if light is incident, so if I consider a ray of light passing through this point and incident on the lens, okay, like this. Consider a ray of light incident on the lens passing through the, okay, like this, and another ray of light like this, okay, fine. Then what happens? After refraction, these light rays become parallel to the principal axis. Okay, becomes parallel to the principal axis. So this is the first focal point. Okay, so first focal point can be regarded as a point on the principal axis. And this point is such that if light is incident through this point on the lens, after refraction the light rays become parallel to the principal axis. So this is the first focal point. Okay, f1. And what is the second focal point? So second focal point. So I think the first focal point is clear. Just let me read out the diagram for second focal point. What is the second focal point? See, if I consider the second focal point, this is the denoted by the letter f2. Okay. So what is this point? What is the speciality of this point? If two light rays are coming parallel to the principal axis, okay, so they are coming parallel to the principal axis. What happens? After refraction they will pass through the point marked as f2. So this is the second focal point. Okay, so second focal point is such a point on the principal axis through which the light rays coming parallel to the principal axis after refraction passes to that point. This is regarded as the second focal point or second focus, f2. So I think the definition or the basic idea for first focus and second focus for a convex lens is clear. Definitely yes. If it is not clear, please move back a little bit. Just watch once again. I think the concept will be clear. Now let us discuss the focal point for the concave lens. So for concave lens, what happens? Just first of all, let us draw a concave lens. So this is our concave lens. Okay, so for concave lens, what happens? The definition is a little bit different. Why different? Let us see. So these are the two focus. So we regard this here as f1 and this as f2. Okay, so first focus is a point on the principal axis. Say if light rays are incident at this point in such a way that they go on to meet on this point, like this. So a light ray is coming like this, it is not actually meeting at the point, but it is appearing to go and meet on this point. Okay, then the light rays after refraction will become parallel to the principal axis. Okay, so this is the first focus or the first focal point. Okay, so the light rays are coming in such a way that in case of concave lens the light rays actually do not meet. We have seen the nature of concave lens. It is diverging in nature, isn't it? So it is here the light rays are coming in such a way that they will tend to meet. If allowed, they will tend to meet at the point f1. Then after refraction, it will pass away parallel to the principal axis. So this is the first focus. Now, what is the second focus? Let us just read out the figure. So, what is the second focus? Second focus is something like this. just the reverse. Okay, just the reverse. What happens here? See, if the light rays are coming, now the light rays are coming parallel to the principal axis. Okay, the light rays now are coming parallel to the principal axis, like this and say like this. What happens after refraction? These light rays tend to move out like this. It appears that as if they have been coming out from the point F2, isn't it? Coming out from the point F2. So this is the second focus or the second focal point. It is the point on the principal axis through which the light appears to be diverging after refraction when the incident lights are coming parallel to the principal axis. So this is the second focus or the second focal point for the concave lens. Sorry. So I think the definitions for the first focal point and second focal point for both convex and concave lens are clear to all of you. Okay, fine. Next, sixth important term is the focal length. Now definitely you can understand focal length. There are two focal lengths, first focal length and second focal length for both concave as well as convex lens. First focal length is the distance between the first focus and the optical center, whereas the second focal length is the distance between the second focus and the optical center. So I think the concept is clear. Focal length is just the distance between the optical center and the focus of the focal points. Likewise, there is another term called the focal plane. So what is the definition of this focal plane? The focal plane is a plane perpendicular to the principal axis drawn through the first or the second focal point. So there are two focal planes, first focal plane and second focal plane. These are the two planes which are perpendicular to the principal axis and drawn through the first or second focal point or focus. So that is the definition for the focal plane. Now many times a beam of light coming from a very far away light source may not be coming parallel to the principal axis, but they are coming parallel. They are actually a beam of light. What happens if they are coming from infinite distance? After refraction, they tend to meet at the focal plane, or they tend to diverge from the focal plane. Or the other way, if they are coming such a way that they are passing through the focal plane and then incident on the light ray on the planes, it is coming from the infinite light source. Remember this. Then after refraction, they will become parallel to the principal axis. So this is the concept. Okay. So I think the concept of focal plane is also clear. Okay. So we have discussed or completed this part of the chapter where we have discussed the technical terms related to the lens. Okay. So today we will be stopping here. In the next video, we will be discussing on from here. We will be discussing the various ray diagrams for convex and concave lens, various rules regarding those. Okay. So till then, please do study well, and if you have any query, you can mention it in the comment section. We will be happy to solve your problems. We will be happy to answer your queries. Till then, please take care. Thank you. Goodbye.